Alright friends, the first principle we want to discuss is inheritance. In object-oriented programming, it is possible for a class to inherit from another class. Suppose we have two classes, animal class and cat class. We can make the cat class to inherit from the animal class. We just need to put the class from which it inherits inside parentheses. In front of the cat class, we are going to put parentheses, then we are going to mention the name of the class from which it inherits, animal. The class that inherits from another class is called the child class, while the class from which it inherits is called the parent class. In this case, the cat class is a child, while the animal class is the parent class. The implication of this is that a child class would be able to access all attributes and methods in a parent class. Now, let's define some attributes and methods in the parent class. Def eat. It takes the first parameter as self because it is an instance method. Print animal is eating. Let's define another method. Def move. The first parameter as self. Print animal is moving. Now let's go and create an instance of the cat class. Cat1 equals cat. Cat1 dot. Whenever you call a method on the cat instance or try to access an attribute, it first checks the cat class to see if they are declared. If they are declared in the cat class, everything works fine. If they are not declared, it will go up to look for them in the parent class. Let's call the eat method on a cat instance. Cat1 dot eat. The VS Code is already suggesting some methods. Let's also declare another class attributes. Animal underscore type equals domestic. Now let's access it from the cat instance. Print cat1 dot animal type. Let's execute the program to see what happens. It turns out that a cat is able to access all attributes and methods from animal due to inheritance. What happens if within the cat class we define a method that has already been defined in the animal class? Let's try that out. Def eat self point cat is eating. As mentioned earlier, the first place checked when looking for attributes and methods is the class itself before going up to any parent class. The expected output from the eat method call is cat is eating. Let's run the program to see what happens. It works. Cat is eating. What you've done here is called method overriding. It involves redefining a method that is already defined in a parent class. The benefit of this is that it allows child classes to implement methods the way they want. But sometimes you may want to explicitly call a method in the parent class. The super function comes in handy here. Now let's make use of super. When you use the super function, you are essentially telling Python to provide you with access to the parent class. So once we add a dot after the super function, the code editor displays the attributes and methods that we can access on the parent class. We can then choose to call any of these functions. Now let's execute the program again to see what happens. Animal is eating is printed to the screen because we are calling a method from the parent class by making use of the super function. Remember that the super function allows you to access attributes and methods on the parent class. This type of inheritance is called single inheritance because we are inheriting from a single class. Alright friends, Python supports what is known as multiple inheritance. This means that a single class can inherit from multiple classes. When this happens, the child class will be able to access all attributes and methods from all these classes. Another question arises: when the same method is defined in multiple parent classes, which one would the child class pick? As you can see, the move method is defined in all these classes. Move in parent 2 and move in parent 3. If we call this method from a child class, which one gets executed? Now let's assume that there is no move class in the child class. We are going to comment out this method Now let's create an instance of child1. Child1 equals an instance of child1. Child1 dot move. We have this move method defined in all the classes parent2, parent1 and parent3. The answer to this question is provided by what we call method resolution order, MRO. Methods are searched from bottom to top and from left to right. Bottom to top means that a method is first searched in a child class before moving up to a parent class. Left to right indicates that it traverses from left to right when searching in parent classes. Now, if I were to run this program, the expected output would be parent2 move. The move method cannot be found in the child class. Then it moves up to search for it in the parent classes, and the first parent class is parent2. When it looks for the method in parent2, the method is found. That means parent2 move would be the expected output. Let's execute the program. Great, the answer is parent2 move. This rule also applies when the super function is used to access an attribute or a method in the parent class. It follows the method resolution order when searching. Let's make use of the super function in the move method, super.move. Alright, so let's change the order of the parent classes. Parent3 to be the first. Now, if I were to run this program, the expected output from this move method call would be parent3 move, because the move method is found in parent3. Let's execute the program again to see the outputs. Parent3 move. A class has the MRO attributes, which allows you to inspect the method resolution order. Print child1 dot double underscore MRO method resolution order. This is going to print out the method resolution order. Let's execute the program. As you can see, the first class is child1, followed by child3, 2, 1, and finally objects. Let's put parent1 to come first. Parent1. Let's execute the program again. Great, as you can see, immediately after the child we have parent1.